Hello, fellow Scratchers. It's been a while, but we are back with a brand new episode of the legendary RPG series, and gosh, is it overdue. Having just coded the very excellent level saving system in episode 10, now we finally get to create multiple scenes and link them all together to create a much, much larger and exciting game world. But how do we keep track of which scenes link together? No problem, we'll do it by giving them clever names, like this one. Over:0:0. This represents part of our overworld map, combined with a coordinate, an X and Y, telling our game where the scene is located on the full map. So as you can expect, that will require some cunning value manipulation, but it's all in a day's work for a Griffpatch tutorial. So are you ready for some RPG coding fun? I certainly am, so find your projects from where we left off in episode 10 and save them as a fresh new copy. For this is Scratch RPG episode 11. Guys, let's get scratching! We need to begin in the level store sprite. This is where all our saving and loading code lives. Hopefully you too have the current scene set to over:0:0, and if not, then you have the option to set yours to this now. Now, why not make the scene name variable visible on the stage? Good. Okay, so our level is surrounded on all sides by bushes. To get past these to another scene, we'll need to clear a path. The 0 key enters the level editor, and the E key picks the empty tile under the mouse, and now I can brush with the empty tile to remove the section of the wall. And can I walk off? No, I cannot, but we have bigger problems to chew on, because when I click the green flag again, oh dear, my level changes have been lost. So before anything else, we'd better complete the saving of any level updates. The obvious time to save is when the user closes the level editor. Right, I can see we already created a load scene event. Similarly, we now add a when I receive store save scene. And don't worry, the custom block already exists for this, save scene. It requires a name to save under, and we use the current one from the scene name variable. Great, that will be perfect. Oh, but before we move on, there's something I just wanted to fix in here. Scroll down to our define new map script. There's a block I want to copy. This set gmul from gmax. There we go, I copied it, and then return all the blocks back as they were before. Now find the define read module grid script. This is where we load up a saved grid list, and again we are setting gmax. But do we set gmul? No, we don't. Well, that could be very unfortunate if the scene size was to change. So paste in the copied blocks now. Phew. Thank you to all the scratchers who pointed that one out to me. Next up then, we can head into the tile sprite. We are looking for the toggling of the level editor. So find the when 0 key pressed hat block. If you're wondering why I have this helpful find bar, it's part of the awesome Scratch Add-ons browser plugin. I know many of you are already using it too. Okay now, we need to be careful. It probably isn't a good idea to save the scene while the main game loop is still running. So broadcast and wait for the stop game loop event to run. Great, so this top if branch runs when we are exiting the level editor, setting editor back to 0. And this is the point we should be saving our scene edits. Drop in a broadcast and wait once more to the new store save scene event in the level store. And look here, this is where we hide the editor layer variable. It makes sense to also show and hide the scene name here too. Duplicate the hide and also hide scene name. Now for the else branch. This is where we open the level editor, and rather than saving, we'd be wise to also force a fresh load of the scene. So broadcast, store, load scene, and wait. Now why load a scene that's already loaded? Well, there's nothing to say our levels won't get modified in-game as the game is played. So restoring the level before we edit is probably a safer bet. We'll also show the scene name variable. And finally, since we stopped the game loop right up here, we'll need to start it back up again with a broadcast start game loop. Now, do notice I didn't use the broadcast and wait here. That was important, as we want this script to end, and the game loop is free to continue on without us. Brilliant, smash that green flag, and we can give that a test. Toggling the editor on and off should show and hide the scene name. Cool. But more importantly, if I make a change to the level and then exit the editor, I'm expecting a green flag click to no longer reset the level. Yes, this time my change was saved and persisted. You just need to remember that to keep the level permanently in your Scratch game, you also need to save the project too. Anyhow, that is awesome. I'll just tidy up my screen by double tapping the scene name reporter to switch it to its more basic form. Okay, saving achieved. Our next task is to get the player walking from one scene to the next. Not so fast. We've already hit a problem. Do you see how we are being stopped in our tracks right at the edge of the level? And this is a bummer. The reason is down to how we store our levels in lists, grid lists, one row at a time, lined up one after the other. This means if we try to check what tile is to the left of this one, we'll find it's the tile from the opposite side of the scene. Well, pants, that's another wall of tiles. No wonder we have problems getting off the edge of the screen. And we can prove this by rushing over to the other side of the level. Gosh, why did I make this scene so big? Hold on to that thought. Now, if I redraw the boundary, bringing the wall of bushes one tile to the left. Okay, so now there's a gap at the right. So dashing back over to the left again, and a slightly confused result, but this is a success when compared to last time. And it is enough for us to trigger a change of scene. Therefore, we are going to add a one tile gap to the right and top of every scene in our game. And yes, that would look bad if we allowed the player to ever see it, so we'll be careful to stop our camera ever scrolling it into view. Okay, if you want to keep your existing scene playable, then we need to take the time to remove all the tiles from the far right and the top rows. It's then up to you whether you restore the border bushes or not. And now we're safe to proceed on to change the camera fencing. The code for this can be found in the player sprite, under the define move camera script. Scroll down to the bottom two if conditions. The first prevents the camera from moving further than the level width, minus half a screen, 240 pixels. Now we want to increase this by one tile, so 240 plus 32 is 272. The same is true for the top edge of the level. 180 plus 32 is 212. Only we must change it on both these lines, 212 for each. Give that a quick test. Speeding over to that right-hand edge. And it's perfect. The right-hand tile is completely hidden. Great, then we should consider our level generation code next. Click back into the level store sprite and find the new map script. This creates a fresh new, fully bordered scene filled with a random splattering of grass and bushes. That's great, except we need to include that one extra tile around the edge from now on. Either that, or we consider scrapping the border altogether since we are now free to walk from scene to scene unimpeded. Well, I'll show you how to do both, and you can make up your own minds. We reduce the body height of the level by one tile, that's now Gmax minus 3. And add it back as a blank top row, add to grid, but fill it out with blank tiles. Now we reduce the body width using Gmax minus 3 instead of 2. And similarly, tack one extra blank tile to the far right, add blank value to grid. Oh my, I almost made a terrible mistake there. The final add to grid that we dropped in at the end was in totally the wrong place. It needed to move up to be before this final repeat. That is for building up the extra 2 layers above the first grid, and these need to be blank. And now a big conundrum. You might notice that I opted to set Gmax to 100 here. That means each scene is a ridiculously huge 100 by 100 tiles. That's 30,000 tiles each when you include height. But now that we'll be able to split our map across multiple connected scenes, I'd much prefer to limit each scene to just 32 by 32 tiles. But if you have already created a fantastic RPG scene, and you simply couldn't bear to lose it, then I'm afraid you're just going to have to stick with Gmax as you have it set now. For me, I prefer to have a fresh start. I am setting Gmax to 33, one more than 32 to allow for that one tile gap. Then, while I have the level editor open, I can click the New Map button, and boom, my beautiful level is no more. But I am now standing in a very nice 32 by 32 bordered scene, which I think you'll find is a far more manageable size to design your game within. So how about we look at generating a fully empty scene next? Well, that's even easier. Instead of all the complex generation scripts, after we set gmul, we just replace them with a single repeat block, repeating for gmul multiplied by 3, one for each layer of tiles. And then we add the blank value to grid inside that loop. Yes, that's all we need for a fully blank scene. Click the new map block again, and there you go. As blank as a blank thing. Just remember, for that new level to save, you need to have clicked new map with the level editor open. Then, when we toggle it off with the 0 key, that causes it to save. And now it's time! Time to code what happens when we walk off the screen. So I'll make sure we can identify our home scene by decorating it with a number 1 and some pretty flowers and a tree. And here we go. We can click into the player sprite. Let's get our bearings. The main game loop is here broadcasting tick player. So find that when I receive tick player script. This deals with the player and the camera movement. So now we need to test if the player has moved out of bounds. Make a new custom block for this called check out of bounds. And be careful not to check the run without screen refresh. I know, leave that well alone. This is because we may want to add in a transition effect later on, and that will certainly require some animation. So drop the new block in right away, check out of bounds. And now let's flesh out this new custom block in some free space. We'll begin by checking whether the player has walked off the left edge of the scene. If player X is less than 0. Then that's it, we need to change scene. So perhaps another custom block is in order? Name it change scene. And follow this with an input named type. We can use this to identify the type of transition. Next, add a label, direction, followed by 2 more inputs, dx and dy. These are to tell us the direction we are travelling in. Once again, refrain from clicking run without lemons for the same reason as before. I do intend to add a transition animation later on. So as before, make use of the new block to change the scene as we walk off the left edge of the scene. Fill in the type as edge, and we'll give it a direction of -1, we're walking to the left, and 0. That's one scene to the left and no change up or down. Does that make sense? Good. To check if we've walked off the right edge of the scene, it's if player X is greater than, and the right edge is calculated as 32, that's a tile width, multiplied by, and then we need Gmax -1 to account for the extra blank column. Plug those together, and update the change scene to move +1 scene to the right. Excellent. Now for the bottom and top edges. Duplicate both ifs, and change all player X's for player Y's. Also, the directions need switching to 0 and -1 for moving down a scene off the bottom edge, and 0 and 1 for moving up a scene. Splendid! If you want to test this is working, you could drop a stop all script into the change scene block and confirm moving off the edge does indeed stop the project. But let's plow on, because this is where things get fun. We are officially changing scenes now, so as we transition, we can stop other scripts in Sprite. This forces the game loop to come to a stop. Also, drop in a wait 0 block to ensure the loop ends before we now continue. If editor is greater than 0, then the editor is active, so we'd better ensure any changes get saved. broadcast, and wait for the store save scene to complete. Fantastic! Now, if the input type is equal to the word edge, then yep, we've just walked off the edge of the scene. In that case, we should check the current scene name. It reports as over:0:0. So this is where we need some clever code to split the scene name apart from its individual X and Y components. Well, okay then, let's make a new custom block, naming it split string, with an input string, a label @ and a final input character, or char for short. And this time, we do check the run without screen refresh. So, given the input string over:0:0 and a split char of colon, this custom block will loop through each letter, building up the individual strings within, but splitting them whenever it finds a colon, and this should result in a 3-item list. Let's create the list first. Name it strings, making it for this sprite only. We'll delete all of the strings to ensure it starts empty. And we need another variable, the integer I, for this sprite only, to keep track of our progress through the string. Starting at the first letter, so set I to 1. And another new variable, string, again for this sprite only. We initialize string to the empty value. And now we can begin the process. Repeat for the length of the input string. So, to store the first letter, make a new variable C for this sprite only. Setting C to letter I of the input string. So, is it the splitting character? If else, checking if C is equal to the input char. That's a colon in our case. If it is, then we can assume we've found the split point. So whatever value is now in our variable string, we add that to the strings list. Add the orange string variable to strings. And then we set string back to the empty value. Now this will make more sense in a moment as we see what to do for letters that are not colons, splitters. That's in the else branch. In this case, we set string to the join of itself string and the new letter from variable C. Finally, we move on to the next letter in the string by changing I by 1, just before looping back around to continue the merry string splitting dance. When this finally ends, and all the letters have been processed, we simply add to the string list whatever remains in that string variable. We are done! Want to see that in action? It's probably a good idea. Split string, some words separated by spaces, and set that splitter to the space character. And then click the block. And ta-da! All the words are split out into individual items in our list. That's so cool, right? And how about a string of numbers separated by colons? Remember to change this splitter to a colon too. And now, again, all the numbers are split out. Isn't that great? We can definitely use this to decode this scene name variable. Just drop it in. And pow, there's our map name and the X and Y positions, all separated out in our list. Perfecto! So scroll back over to our define change scene custom block and we'll finish this baby off. If this is an edge transition, then split the string, scene name at the character colon. Let's sanity check that result. If the length of the string list is 3, then that's as expected, a map name followed by an X and Y position. So now we can use these strings and the dx and dy inputs to calculate this scene name we are transitioning to. Set scene name to item 1 of strings. That's the map name. Over. Next up, we need the X position. Set tmp, temp, that's reusing an existing variable, and we need an addition block. Summing item 2 of strings, that's the scene's X position, with the direction dx input variable, That'll be -1 for transitioning left and 1 for transitioning right. Finally, append this to our scene name. Set scene name to the join of scene name and another join block because we first require a colon and then that TMP temp variable. That's the exposition updated and restored. Now we'll do the same for the Y. Duplicate the last 2 lines, only switching for item 3, the previous scene's Y position, and add to that the DY input variable. Nice, the next line remains unchanged, and our translated scene name should be complete. Don't worry about the else branch down here for now, we'll come back to the other transition types another time. Think doors, holes in the ground, stairs, goodness knows what else we might need down the road. So, yay, we're close, can you feel it? Broadcast and wait for the store load scene message to complete. Now, what if the requested scene doesn't yet exist? Well, no problem, because our load scene script is set up to create a new scene in that case. Wow, how clever of us. Now, wowzers, we've done a lot of coding. We may not quite be done, but it's high time we tested our work. So smash that green flag. We can confirm we begin at scene over :00. Now, what we hope is that by walking off the left edge of the scene, stupid list in a way, that the scene name changes to over -1, 0. Exactly. Yeah. So pleased to see that result. But we didn't see the scene change on screen because the project stopped. And that's expected, as we never restarted the main game loop anyhow. So if I hit the green flag again, now we find ourselves in the new blank scene at -1, 0. So now we can try walking off the right-hand edge of the scene instead. That should return us to over 0, 0. Perfect. And of course the project stops. So can we just start up the game loop and all will be well? No. There's one more thing we haven't considered. When a player walks off the left edge of one scene, we'll be expecting them to wrap around, appearing on the right edge of the scene once more. Okay then. So if type equals edge, then we have walked off the edge, so which one was it? If dx is equal to 1, then we are walking to the right, so we must appear on the far left of the next scene. Set player x to 0. That one's easy. Let's duplicate this for dx equal to -1. The maths for the right edge of the level is 32 multiplied by, and we drop in the result of subtracting 1 from Gmax, Gmax -1. Great! A simple task of duplicating both cases now, and switching the dx's for dy's. And the player x's for player y's. Job done! And now we can restart the main game loop. Broadcast, start, game loop. Remembering that we mustn't wait for the game loop that isn't going to end. Okay, wow. Hide them variable reporters and lists. They just clog up our beautiful screen. For it is testing time, baby! Smash that green flag. Here we are on scene 1. Over 0, 0. I'm walking left, and we've transitioned to scene over -1, 0. And the player is indeed now entering from the right edge of the scene. That's excellent. Walking back, and here we are again on scene 1. And we're at the left edge. Let's try moving down. Oh yeah, that is what I'm talking about. Scene over 0, -1. That's 1 below the first scene. And I can confirm we currently entered from the top of the scene. And finally, back up to the first scene. That works for me. Tell you what, an even better test would be to go back and lay down some rocks. And now we can confirm that the new scenes are indeed saving and that we can revisit the same ones consistently. I wonder how many scenes we can extend this to. Quite a few, I expect. Hey, wait a minute. Are you seeing that? I'm experiencing a bit of scene flicker as I change scenes. It looks like we are seeing a flash of the bottom of the first scene as we enter it, and then it reverts to normal. It's most likely that we just need to move the camera to the player after switching scene. To confirm this, simply drop a move camera block right before the broadcast to start the game loop. Shall we try that again? Let's see. Yeah, that was the problem. Excellent. Because that means we have reached the end of another episode. Now, I really hope this has helped you Scratch RPGers expand the horizon on your game worlds. I'm well aware that there's still oodles of features to be investigated and code to be written. So if you want more, you must smash the like button right now, share this video with your friends, and simply make as much noise about it as possible. Watch it 3 times and click on all the ads. Whatever it takes to get YouTube to notice that we want more. Also, if you don't want to miss any videos that I post, then do ensure you subscribe to the channel and tap the bell icon so you get notified the moment the next video drops. I've had a lot of people ask whether I have any merch, especially around the holiday season, and yes, now I do. So you too can be a true Griffpatcher and own a splendiferous Griffpatch mug, just like mine. Or a bag, t-shirt, whatever takes your fancy. But on that note, this is the end of the video, so thank you for watching. Do have an excellent week ahead, and scratch on, guys.